Use Simpson's rule with uniform strips to estimate the value of the integral from 1 to 3 of e to the x dx. Estimate the percentage error in each case. So for n equals 6, just as we did with the trapezium, we'll do this a bit more manually. So our delta x is going to be 3 take away 1 divided by 6. So that's 2 over 6, which is 1/3. So if we look at our x's, our x0 is going to be 1, the lower limit. Then x1 will be 1 1/3. x2 will be 1 2/3. x3 would be 2. x4 would be 2 1/3. x5 will be 2 2/3. And x6 would be 3, which is the upper limit. And we want the corresponding y values. And once again, I'll use the calculator to get these. So I'm going to go to graph and table again. And we want this to be e to the x this time. So let's put in e to the x. And we want a table. And I would like my table to start at 1, end at 3, and have a step of 1/3. Okay, and here we have the values. I'm just going to pause the recording while I write them down, and I'm going to do them to 6 decimal places, just like I did with the trapezium rule. So I've got all the values now. Notice that I've labelled them y0, y1, y2. This is going to be really important when we're doing Simpson's rule. And now we want to write down the rule and substitute our values. Remember, you won't actually be asked to do this in an exam. So we have delta x divided by 3. So in this case, that's going to be 1/9. The first and last values go in just the ones. Then we have 4 times the odd ones. So the first odd one is y1. So that's 3.793668, and so on. The ones that will go in there are this one and this one. And then we have 2 times the even ones, which are just going to be that one and that one in this case. So 5.294490 and the other one. And then we're going to calculate that. Now, in actual fact, I'm not going to type all this into the calculator and do it. I'm just going to go back to the E activity. I'm going to go for the numerical integration. It's the same one. I'm going to change the function at the top here to e to the x. And we are going from 1 to 3. And we'll do the 100 shortly because that's part B of the question. So let's just do our one with 6 strips here. And we are going to execute that. And you can see the true integral here, which we're actually going to need because we want the percentage error. So I'm going to write that one down just up here for now. 44771525. And then I want to find my Simpson's rule, which is the one just above it here. So 3.4477 if we go to 4 decimal places there. But let's make a note of that one. 3.44771525. Wow. So 0% error. It's exactly the same number. And that suggests I'll get a 0% error when we do the 100 as well. Let's just do the 100 while we're here. And we can see they are, in fact, the same number. And in fact, the same number as we got before. It's super accurate, super quickly, is Simpsons. If there were more decimal places here, of course we'd see differences. And the one that we've just done with 100 would be more accurate. The only time that they're ever completely accurate to the same number of decimal places, because we use parabolas for Simpson, is when we're actually dealing with a parabola.